The profile server, as mentioned, it stores the generated SIP UA configurations and the uploaded files from the SIP UA. So when your phone generates a log file and uploads it, then that gets stored on the profile server. It generates and stores call center reports. So the data lives in the DBS, but it generates it. Profile server is actually what runs the code that goes and generates the report. It manages the database structure on the DBS, and then it monitors the DBS for active standby status, so it decides which DBS it's going to actively use. So Oracle has its own methods for active backup failover, but the rest of the network, the application server, for example, has to know which of the two IP addresses to talk to. So here's a view of that, of a call center report, just to give an example of the kind of things the profile server could generate. So it is showing here the number of hours that the different agents were in different statuses. So you've got these different call center agents. They're available, they're unavailable, they're in the middle of a phone call. It shows here that the total time here was 1 hour and 47 minutes and 18 seconds. And that they were talking 27 minutes and 47 seconds of that time. But these graphics, the rendering, the shading, and all that stuff, that's done by software running in the profile server. Thanks to Momentum Telecom for this example. So the DBS runs Oracle RDBMS. It stores the call center activity and the call logging, enhanced call logging activity right now. And in both cases, the data is sent by the app server over to the DBS. And so it's not trying to do any logic. Basically, the DBS's job is not to crash, not to lose track of data, but it doesn't generate any reports. It simply receives data, and then when you have other applications that want to get data, the DBS sends it back. So we'll talk just briefly about these legacy servers, the UMS, USS, and UVS. They implement the features necessary to do these things. So here we have our friends at Evolve IP provided this graphic publicly. But basically, this is them, several of their staff members running a call. The messaging server is what enables the chat messaging between it. So you can imagine if you're in a financial services context, then the messaging server is where those messages are going through, and you have to keep a copy of all those because of the regulations that says you have to record all the communication that happens. So the messaging server is where that happens. The Screenshare Server is used for when I connect to one of these calls, I want to share my screen. Well, it handles the software processing to get that video image from my screen and then distribute it. And then the video server renders multi-party video for UC-One. And it functions as a kind of video MCU, a multi-point control unit, by taking in all these video streams and then deciding what it should look like on the output side. These are not a major part of this class. As I mentioned, they're not in scope here. The AMS, the Access Mediation Server, is also not a major part of this class. It operates as a interworking device between Skinny phones, SCCP, and BroadWorks phones. It does some SBC-like things, and it's added to retain compatibility with Skinny devices. So years ago when BroadSoft bought a vendor, that vendor, I believe it was Genband, they bought in a product that had support for Skinny phones. And so in order to integrate those users, bring them into the BroadWorks ecosystem, they have the AMS as a translation device. So for example, the phone on the screen is a Skinny phone, and it would communicate to the AMS, and it would communicate Skinny on between the AMS and this phone, and then the AMS would speak SIP on the core side and interwork between the two. And then it would talk to the app server. The AMS would communicate SIP to the app server. The WRS, the WebRTC server, is a link to BroadWorks from the WebRTC standard. So this is a JavaScript calling API. That's what WebRTC is. So you can write applications in JavaScript that have access to audio and video devices on your device without having to use a special driver or plugin like Adobe Flash in order to get that. And so basically the browsers implement the code that's required to speak to your audio and video devices, and they allow you to build web pages that can make audio and video calls. Well, we need a way for those type of calls to connect through to BroadWorks, and that's what the WebRTC server does. So you can, from the slide, you can use that demo. You can watch that demo video of WebRTC. There's some speculation that WebRTC may not be long for this world. It's within the WRS, in particular, the service. The technology is very useful. It's been used in a lot of different contexts. The question is whether Cisco is going to maintain this. It has some usability, and there's some function in it, but it's not a major part of the BroadWorks ecosystem, and we're not going to cover it a ton in this class either. I wanted to cover a little bit of something that's new that's happening that a lot of service providers are going through right now, which is the UC-One SaaS integration. So this is where you're connecting your BroadWorks system to the Cisco infrastructure, so the UC-One SaaS software as a service system. So let's walk through this. This comes from the Cisco UC-One SaaS reseller guide, and we'll go through a little bit of this and see what's going on. So we've got a couple of different apps here. There's UC-One, and then there's the Meet app that can call to each other. So the let's just get a lay of the land here. Basically, on the left-hand side, we have BroadWorks components that would run potentially in your network as a BroadWorks service provider. Then we have in the middle, we have the servers that are part of they're hosted in the Google Cloud platform, and they're operated. These are kind of BroadWorks particular servers that are running the services to enable this UC-One SaaS product. And then we have on the right-hand side, we have running in Amazon, we have the Cisco server. So basically, you got WebEx Teams and then Cisco Identity, which is what enables you to have a single login synchronized between the Cisco universe and your BroadWorks universe. In addition, they have a couple of other things they're showing here, like the Apple push notification or Google Cloudflare notification, Google Cloud notification, and then there's a mail server that's used to deliver outbound emails. When UC-One starts up, it's going to speak over XSI to your XSP, and it will to initiate, to log in, to determine what it should get, what kind of configuration it should get. But principally, what this is focused on is the ability to place calls and to provision the calling platform. So just a few things to point out. One is how UC-One connects over to WebEx Teams, but it also connects over here to the BroadWorks service provider. There's a few lines here that are left out somewhat, but there's communication between UC-One SaaS and servers that are running in Google Cloud platform and the service provider application server. So these things have some connectivity between them. What they're not showing here is in most cases, the calling that would happen. The calling is functionally going to happen between the UC-One app and your BroadWorks system. So you're going to have SIP and RTP that is communicating between the UC-One app and your BroadWorks system. But there's also the ability to have media flowing in the other direction. For example, to talk to the UC-One, the Meet application, and then also to set up WebEx Teams meetings. So really what they're trying to do is vacuum up all the possible calling and meeting platforms that they have and make it possible to use them all. But what they're not trying to do is provide a calling platform that replaces what you already have. Most of the users who are interested in this product already have a way of placing and receiving calls. They already have phone numbers. They already have contact centers. They already have call forwarding set up and all the other things that they would need. And while, yeah, you could take your service away and move it over to there, in most cases, Cisco's not scaled up to enable that level of calling. They're not even trying to offer that level of a migration service. They know that if you're CenturyLink and you're Verizon, that you already have millions of users running in your platform. And they're not trying to pull those in. What they're trying to say is, well, CenturyLink, you can let your users have a CenturyLink phone number and CenturyLink voice services, but you can also let them connect into WebEx team meetings, and they can have the same identity in both worlds.